where they talk about that if you cannot store the data on one machine, how you can divide the data and store it on multiple machines. Now, you remember when we talked about what are the requirements to design a good big data system, there were three things we need to deal with. The first one is storage, which they have covered here. Second one is processing, and third one is scalability. Now, scalability will be taken care because whatever they are giving is based on a distributed architecture. So scalability is taken care. Storage they have given already. Now what is remaining is processing, and that's what they have given in the year 2004. In 2004, they said, okay, we have already stored the data. We have already stored the data on a cluster of machines in a scalable manner. Now let us worry about processing it. And this time they gave a paper on distributed processing. You can think it that whatever C program, Java program, Python program you used to write, used to take the data from one machine and solve the problem. But now things are no longer the same. The data is not sitting on one machine anymore. The data is sitting on multiple machines. And that is what they have given an idea that when data is stored on many machines, how to process the data. Because your traditional programming models do not work now. Your traditional programming models only work when data is stored on a single machine. Data is stored on a multiple machines now, so your traditional programming models do not work, and a new programming model was required, and that is what they have given in the year 2004. And this paper on distributed processing is called as MapReduce. If someone is very curious, you can see HDFS and MapReduce paper on Google. The official papers will be available. So sorry, GFS paper and MapReduce paper on Google. GFS is for distributed storage and MapReduce is for distributed processing. These are the two papers given by Google. Now these are just the papers. Now papers are good to some extent, but someone should implement, and that's where Yahoo came to help. So what Yahoo did is that in the year 2006, Yahoo took these two papers given by Google. Right? Google gave the papers in 2003 and 2004. The papers were GFS. GFS was for distributed storage and MapReduce for distributed processing. But those were just the theoretical concepts. Yahoo took these papers and they gave implementations or built softwares on top of it. Right? So the implementation of GFS was named as HDFS. That means Yahoo took the GFS, Google File System paper, they implemented it, and the name they gave to this is HDFS, which stands for Hadoop Distributed File System. Many of you might have heard this term. Also, they took the paper MapReduce, they implemented it, but in this case, they have not changed the name. The name is still kept as MapReduce even after the implementation. That means from GFS, we got HDFS as the implementation, and from MapReduce, we got MapReduce as the implementation. So basically, we have two things now. HDFS. What is HDFS for? Distributed storage, because data is not stored on one machine. Data is stored across many nodes across the cluster. And we have MapReduce. MapReduce is for distributed processing because data is kept on many machines. Now there is a requirement for a processing model which can take the data from many machines and process it. And MapReduce do that. None of your traditional models do that. So HDFS is for distributed storage and MapReduce is for distributed processing. Right? And these two form the core components of Hadoop in the very first version of Hadoop. So if someone asks you in the very first version of Hadoop, Hadoop 1.0, what are the two core components? So the two core components of Hadoop 1 are HDFS and MapReduce. HDFS is for distributed storage and MapReduce is for distributed processing. So I hope you should be very, very clear with this now. right? So you understood that we get this HDFS and MapReduce, and these two form the core components. Now in the year 2009, Hadoop came under the Apache Software Foundation and became open source. That means from 2009, it became open source and anyone can see the source code and anyone can contribute to it. This is the difference between free and open source. Free means you can use it freely. Open source means you can even contribute to it. The source code is available publicly. For example, tomorrow, if you see some bug in Hadoop, you can report it, you can solve the problem, and you can even code for it, right? Now, in the year 2013, Apache released Hadoop 2.0, the second version of Hadoop, which has major performance enhancements. We will talk on this later in some time. So this is how the Hadoop evolution is. In 2003, Google gave a paper on distributed storage. In 2004, Google gave a paper on distributed processing. And in 2006, Yahoo implemented these papers. And then 2009, it became open source. And 2013, we got Hadoop 2.0 with major performance enhancements in Hadoop 2.0. Now, this is what the difference is between Hadoop 1 and Hadoop 2. Now, let me tell you what was the main challenge with Hadoop 1. The major problem with Hadoop 1 was that they felt, or the architects felt, that this MapReduce is a very bulky component, or MapReduce is such a big component that it has to do a lot of activities, and it was getting stuck there or getting bottlenecked there. If someone has to do a lot of work, right, it gets bottlenecked unnecessarily. So what they felt is that, is there a way we can break this Hadoop, or we can break this MapReduce so that we can take some portions of its work and give it to a new component. So consider, let's say if MapReduce was doing 100 things earlier, what they felt is that, is there a way that we can take some 40 activities from this so that MapReduce can work only on 60 easily, and the remaining 40 we can give it to someone else. So that is what they did for. So what they did is they broke this MapReduce into two parts. One is still called as MapReduce with a limited set of functionality, and another one is called as Yarn. So that means Yarn took some of the capabilities of MapReduce and came as a new component. But having said that, Yarn possessed some new capabilities also, which were never there in MapReduce. That means Yarn possessed some capabilities of MapReduce plus some new capabilities also, which were never there. So this is one of the change in Hadoop 2, that Yarn was introduced and MapReduce functionality was split into two parts. Now we will see what is Yarn in some time from now. And also do not feel that this is only one of the change between 1 and 2. As of now, we have seen one change. Later throughout the course, we will see multiple changes which are, or multiple differences which are there in Hadoop 1 and 2. This is just one of the main architectural change that Yarn was introduced. So what is Yarn? We need to understand that. So before that, let me ask you, what is Windows on your system? Windows is nothing but an operating system, you know that, right? Windows is operating system. What is the role of Windows, or what is the role of operating system? Operating system is mainly used to manage the resources efficiently. For example, if I'm using Windows, then it will help me to manage the resources on the system in a very graceful way. Think Yarn like an operating system only. But Yarn is not just running on top of one system like Windows. Yarn is running on top of multiple systems or across the cluster. For example, let's say you have a cluster of 100 nodes. So think Yarn is an operating system sitting on top of those 100 systems or 100 nodes and managing the resources underneath. That means it does not manage the resources of just one single machine. It manages the resources of all 100 machines as a pool of resources. That means if someone needs resources, they will contact Yarn and say, can you give me resources, please? Yarn is the sole owner of the resources and will manage the resources in an efficient manner. The full form of Yarn is yet another resource negotiator. That means if someone wants resources, they will negotiate the resources from Yarn. And Yarn is mainly responsible for resource management. That means Yarn is nothing but a resource manager or like an operating system in a distributed environment. So this is how it looks like, or the three core components of Hadoop looks like in the second version of Hadoop. Because in first version only HDFS and MapReduce were there. But in the second version of Hadoop or Hadoop 2.0, we have three core components. HDFS for storage, or I should rather say distributed storage. MapReduce for distributed processing, and Yarn for resource management, just like an operating system. This is the diagram I am showing you for Hadoop 2.0. So if someone asks you, can you tell me what are the three core components of Hadoop in the second version of Hadoop? The three core components are HDFS, MapReduce, and Yarn. HDFS is for distributed storage, MapReduce for distributed processing, and Yarn is a resource manager. Now, if someone has some idea about Hadoop or big data, you might have heard of variety of things like Hive, HBase, Pig, Scoop, Flume, Oozie, Zookeeper, Spark. A lot of things are there. Let us understand what are these things and how does these things fit in with Hadoop. So basically, we have the Hadoop core with three things: HDFS, MapReduce, and Yarn. And there are a bunch of ecosystem technologies that surround it. And this is how it looks like. Some of the crucial or important ecosystem technologies which you should know are Hive, HBase, Scoop, Oozie, Pig. Even though I have kept Pig, but Pig is not that important these days. Spark. Spark is very, very important, right? We will talk more on that. But think that these are the ecosystem technologies surrounding the Hadoop core. At the core of it, or at the heart of it, lies the Hadoop core. And there are a bunch of ecosystem technologies which surround. And this together is called as the Hadoop ecosystem, as mentioned here. So if you encounter this term Hadoop ecosystem, this is what it looks like. Now let us try to touch base on this ecosystem technologies at a very high level. Now let me tell you one thing, or let me ask you one thing. What is the processing unit used in the Hadoop core? Now everyone knows it is MapReduce. Now what is the kind of code we have to write for MapReduce? In which language we need to write? Or in which programming language we need to write? So the code written for MapReduce is mostly in Java language. And Java is not something which everyone is familiar with. Most of you might not be aware of Java. If you do not know Java, does that mean you should not be able to work on Hadoop? No, absolutely not. It does not mean that. Hadoop should be open to other people also who do not know Java. And that is where Hive comes for the rescue.